So here in 5.2, we want to begin looking at something called inverse functions. But in order to really look at inverse functions, you have to have something in the background called one-to-one functions, and we want to look at one-to-one functions. So let's review our definition of just a function in general. So we talked about this definition way back, I believe, in our first unit, if you can remember the first unit where we looked at functions. So what is a function? A function, f, is an association between inputs, which we call x, and outputs, which we call y, such that for every input, for each input, there is only one output, y. So what is a function? So over here you have the inputs, which we call the domain. These are the x's. And over here we have the outputs, the range. These are the outputs, the y's. And a function is an association between these values. And remember, for each input, you're only allowed to have one output. So f is a function here in this little example I'm drawing. Let's do another example to show something that is a function. So we have x1, x2, and x3 as our inputs, and over here we have our outputs, y1 and y2, and let's say the association does something like this. This is still a function, right? Every input has exactly one output. Every input has exactly, x1 has one output, x2 has one output, x3 has one output. So f is a function here. Let's do an example of a diagram which would not represent a function. Here we have domain, x1 and x2, let's say, are our inputs, and over here, let's say we have our range, y1, y2, and y3. And let's say the arrows of association go like this. So here, f is not a function. And the reason being because we have an x that goes to multiple y's, f is not a function. So to be a function, every x can have only one y value. Notice that one of our x's here, x2, has multiple y values. So it's not a function. And remember, if you wanted to test a graph, whether or not it's a function, you use something called the vertical line test, Okay, so we want to talk about a more specific type of function, not just a general function, but a specific type of function called a one-to-one function. Definition, a new definition. What is a one-to-one function? A function f is one-to-one. So it has to be a function number one, but it's a one-to-one function if the following happens. For each output, y, there is only one input, x. So to be a function, every input had to have only one output. But to be a one-to-one function, you additionally have to have that every output has only one input. So I'm going to draw some diagrams here. So here we have the domain on the left, the range on the right, and we have our inputs are x1, x2, x3, and our outputs here are y1, y2, y3. And let's say our arrows take x1 to y2, x2 to y1, and x3 to y3. So f is a function, but it's also one-to-one. F is a one-to-one function. So every x goes to one y, and every y only gets one x. So this is a one-to-one function. Let's do another diagram that's not representative of a one-to-one function. So we have domain, we have range. So we have x1, x2, x3 in our domain, and our range we have y1, y2. And let's say our function, or our association, our function, has the following. x1 goes to y1, x2 goes to y1, and x3 goes to y2. So f is a function, but it's not one-to-one. So it's a function because every x has one y, but it's not a one-to-one function because every y does not have one x. Okay, so here's some kind of follow-up to this. Examples. Oh, so I have to follow up with this. When is a function one-to-one? So criteria for testing a graph of a function for one-to-one-ness. In other words, when is a function one-to-one? So first of all, it has to be a function, has to pass the vertical line test. But it's going to be a one-to-one function precisely when it also passes what's called the horizontal line test, which will state that. So a function is one-to-one if and only if its graph now let's say it this way, not its graph. Every possible horizontal line passes through the graph at most one time. This is sometimes called the horizontal line test for one-to-oneness. One-to-oneness. So the idea is, let's say, okay, let's just do some examples where we use the horizontal line test to test for one-to-one. So we're going to look at some functions, some famous functions from our library of functions. Determine if the function is one-to-one. So they will be functions, but they may not be one-to-one. We'll see. Number one, we have the function x cubed, right? That's a very famous function. If you remember the graph of x cubed, this is an important one. I'm not going to be accurate, but it looks something like, let's make it red. It looks something like this. Now, does that pass the horizontal line test? If I take a horizontal line, does it only pass through at most one time? Yeah. So yes. F is one-to-one. Number two, if I look at the squaring function, x squared. Well, let's graph that real quick without getting into too much detail. It's a parabola, right? It has a vertex at the origin. If I take a horizontal line up here, it's going to pass, it's going to hit more than once. So it's not going to be one-to-one. It's a function, but it's not a one-to-one function. So here, no, f is not one-to-one. Now, let's actually think about that. Why? So imagine taking the point over here, I don't know, let's say this is 1, 1, right? This is 1, 1. Sorry, negative 1, 1. And this point over here is 1, 1. So if I did like an XY table, right? I'd have negative 1, 1 and positive 1, 1. So we could see that we have two different x values, right? Negative 1 and positive 1, both going to the same exact y value. And remember, with a one-to-one function, every y value is only allowed to have one x value. So here we have a y value that has multiple x values, so this would not be one-to-one. Okay? So just the quick way is just to use the horizontal line test. But that's the reasoning behind it. Okay, let's say I take the square root function, the famous square root function. If we were to graph that out generically without getting into much detail with the points, it would look something like this. And that definitely passes the horizontal line test. You might think that up here it doesn't. It does actually, because this graph continues to increase forever. It doesn't ever go horizontal, that graph. So yes, it does pass the horizontal line test, so yes. The square root function here is 1-to-1. Let's look at another famous function. How about the reciprocal function? The famous reciprocal function, f of x equals 1 over x. Remember, that's a strange looking one. It has a vertical asymptote and a horizontal asymptote. And it has something up here in the upper right corner and something down in the lower left corner, and there's no horizontal line that hits more than one time. It's at most once. So yeah, it's 1-to-1. Yes, the reciprocal function is 1-to-1. Okay, we'll do one more final example. And we'll talk about the absolute value of x. I mean, the absolute value of x, when we graph that out, that's a v, right? And clearly this fails the horizontal line test. All right, we hit twice when we do a horizontal line. So no, f is not